Well, good morning, good afternoon, good evening, everyone, and welcome to the world's most exciting classroom. My name is Joe Grabowski, and I'll be your host for today. This is our second event geared towards classrooms in Australia, New Zealand, and the surrounding areas. We have been doing the world's most exciting classroom ever since the Oosterschelde set sail all the way back in August 2023 from Plymouth in the United Kingdom. We're on, I think tomorrow will be our 60th world's most exciting classroom for that part of the world. But from now until the end of the journey in July 2025, we'll be doing a weekly event for classrooms in this part of the world. So let's start off with a quick share screen here. Let's catch up on the map and see what's going on with the Oosterschelde. So my screen should come up right about now. There we go. I'll make this full screen. So you can see we are still in New Zealand. Now, it looks like not much has changed with the ship in the last few weeks, and that's absolutely true because we have been undergoing maintenance. Over the last few months, we crossed the Pacific Ocean, this massive expanse of blue water on our planet, and the ship was in some desperate need of a little bit of maintenance before continuing on with its journey. Now, it's not sitting idly right now. We have a group of Darwin leaders on board. So young 18 to 25-year-olds from around the world who are showing promise in future careers in conservation. They're on the ship right now. They're working with local conservation organizations in New Zealand, training, making videos, social media pieces, and things like that. And hopefully they'll take those new skills back to their home countries and be future conservationists going forward. So those Darwin leaders are on board right now, and we'll get to meet some of them over the coming weeks and learn about some of the projects that they were working on. In a few days from now, we are going to set sail for Auckland, where the ship will just be there briefly. There'll be an open day where people can come on board and see the Oosterschelde. We'll have a new set of passengers and a couple researchers come on board. Then we'll make our way across to Sydney, take us a couple of weeks, and then we have a huge series of events. In Sydney, we'll do a bunch of live streams. We'll have the Opera House one day where we'll do some events for the public before we move on to Hobart in Tasmania. So lots happening in the next few weeks. I'm going to come back from that screen share. One thing I've been trying to do is share a little bit of content from the journey so far. And what I want to share with you now is a tiny little video clip of one of the first marine mammal sightings we had after we left Plymouth and set sail. So I'm going to share this clip with you, and then you'll get a little feel for one of our first sightings. And let me tell you, it was a big one. You'll see what I mean when the video plays. All right. Make sure I pick the right one here. Where did it go? Ah, I see. I've got the wrong section on my screen open. There it is. Here we go. All right. So that was a fin whale, second largest creature on the planet, and one of our first major sightings after we set sail from Plymouth. We were making our way kind of towards the coast of France and then onwards towards Spain. So that was really cool. Now, one thing that you guys haven't had a chance to experience yet is actually seeing the ship. And that's because there's no camera people on board right now. We haven't had the researchers on board while it was undergoing maintenance. But next week's event, we should have a live connection from the ship as it's sailing towards Australia. So you'll get to meet some of the people on the ship. One of my good friends, George Krunis, is the researcher on board. You'll get to meet him. You'll get to see some of the ship. So that'll be really, really cool. All right, let's get right into tonight's event. We have our guest speaker joining us tonight. He is joining us from New Zealand. We have Dan Tompkins joining us. He is a science director with Predator Free 2050 in New Zealand. And they have a pretty ambitious goal of wiping out invasive stoats, rats, and possums in the country by 2050. So I'm going to grab Dan from backstage and bring him in with me right now. Hey, Dan, how you doing?
Hey, Joe. Good to see you. Yeah, doing well, thanks.
Yeah, good. Great to have you with us, Dan. What part of New Zealand are you in?
So I'm down in Dunedin, which is down towards the bottom of the South Island. So we're still a bit cold, still a bit wintry, wearing the pulley at the moment still. Looking forward to summertime.
All right, there you go. Well, we're really kind of stretching today's event. I'm in Canada, you're in New Zealand. Things are getting colder here, whereas I imagine they're getting warmer for you there. So we're
Yeah.
flipping seasons.
Yeah, no, it's always good this time of year for us, but not so good for you guys.
No. All right, Dan. Well, we want to get into this. We want to learn a little bit about what you get up to. So let's let you take over for a little bit. Then we'll take some questions.
Sure, all good. Well, kia koto. Hi to everyone listening in. As I said, my name's Dan Tompkins. I work for a company called Predatory 2050 Limited. And we're trying to progress a national conservation mission here in New Zealand, where we're aiming to try and eradicate some invasive mammals from the entire country for the benefit of native biodiversity. And so what I'll do just now for about 15 minutes is show you a few slides, show a couple of videos, give you the reason why we're doing it and how we're getting on. And then happy to take any questions and comments afterwards. So why are we doing this? And so why does New Zealand have such a large invasive species problem? So this is a picture of this part of the world from about 100 million years ago. And in the green there, that's land, and the blue is the water. The grey bit below is the Antarctica plate, so don't worry about that for now. And I'll just show you a little video, and what you'll see is the process by which New Zealand separated from Australia over time and what happened in between. So I'll just click go now. So this is the sea coming in and New Zealand separating off. And then around about 30 million years ago, most of New Zealand was actually underwater. And so it's only been since then that we've re-emerged to be the country that you know today and the country that the boat is currently moored up at. And so what this drowning period did is it means that a lot of the terrestrial fauna and flora was heavily impacted, such that even today, we only have two species of native terrestrial land mammal in the whole country. So because of this drowning, things like birds and insects could recolonize from Australia, but the mammals that have to walk everywhere, they couldn't make it. And so all we have left in New Zealand then is a great native assemblage of flora and fauna. We've got about 80,000 endemic species. We've got birds like the kakapo, reptiles like tuatara. We've got native insects like weta, and some of our trees are pretty fantastic. This is a pohutukawa, and these will be flowering up around the Auckland region pretty soon. But what happened as mankind has discovered New Zealand? Before people came here, pre-human settlement, maybe about over 1,000 years ago, there was only two species of terrestrial mammals in the entire country. And they were both bats, because of course bats could have been blown over from Australia. We had a third bat species that's now extinct. Every other mammal that you see on the land in New Zealand these days has been brought here by people, either intentionally or accidentally. And so from the 10th century onwards, with the initial Polynesian settlement of New Zealand, two species were brought then with people. We brought the Polynesian rat, or the kioi, as we call it in New Zealand, and the kuri, or the Maori dog. And these two came with the original settlers of New Zealand from Polynesia. And then as Europeans discovered New Zealand, a whole load more species came in the 18th century with Captain Cook and whaling fleets, brought in more rodents and goats and pigs. And then with European settlement from the 19th century onwards, a whole new other range of species, so mustelids, rabbits, deer, and not being content simply bringing species from Europe, the settlers also stopped on way in Australia to pick up things like possums and wallabies, and they brought them down as well. So we have around about 35 invasive mammals in the country, and we have a flora and fauna that's evolved for about 20 million years now in the absence of these mammals. And you can imagine what the impact is. They're just not ready for it. And so this is a government report that was done back in 2017, where it really highlights the issue is ongoing today, that 80% of the remaining native bird species in New Zealand, they're still under a great amount of threat from these introduced species, mainly the introduced predatory mammals. And these are the targets of the Predatory 2050 mission. And this is why we're doing it, is that we need to actually remove these mammals that shouldn't be here to allow New Zealand's native species to flourish. And I'll just start off with one or two videos quickly, just to give you a feel for that and how we're going about trying to do it.
The West Coast really is an untamed natural wilderness. The Waihi is a World Heritage Site known for its extraordinary landscapes. And now we're embarking on a hugely ambitious project that has the potential to transform not just South Westland, but all of Aotearoa.
It's an awesome opportunity for jobs and for nature. And the best thing is, we've already proven we can do it.
Zero Invasive Predators has recently removed possums, rats, and stoats from 12,000 hectares in the Perth River Valley.
Yeah, for a start, I was sceptical, as a lot of people in South Western were. As the program's gone on, as we're seeing the results, we're all pretty happy now that it's making a big difference. The technology, the monitoring, the cameras, the traps, systems seem to be working really well, yeah.
If we can do it here, we must be able to do it anywhere. So what happens next is we're going to scale up what we've already done here. We're going to be doing it in this kind of landscape, rural areas, and also in local townships. And we'll be doing it with the community. To be pest-free without the risk of TB for our farmers is massive. And it will increase the bird life that we enjoy seeing out here for anyone who comes to visit this special place.
We run a wilderness tour business out on Lake Maparika here. People often do comment that the bird life is really silent out here, which is difficult.
I've been trapping around the lagoon here now for 7 years. Each year I notice there's less of some species. What we're trying to do is protect the fernbird and bittern. Also kotuku, the roe, New Zealand's rarest kiwi, which lives in the hills around here, and other wading birds. Oh, nobody home, that's good. But what's changed is that we can actually eliminate predators from these sort of large, extensive areas of wildland. I can see maybe in a year or two, I won't need to trap around here.
Predator-free South Westland will work over 100,000 hectares, from the Whataroa River and Perth River Valley to the Waio River at Franz Joseph. Natural barriers like rivers and mountains will keep most predators from reinvading. Those that do break through will be caught using a network of smart traps and detection devices.
So this is the latest technology we're using in the field. It's an AI camera that tells us exactly when and where we have predators. Hopefully with the technology and the gear they've got now, then they don't need to keep 1080. I think the community will be happy about that. You know, at least 1080 better. Hunters were worried that the animal numbers would get knocked down really low, but we've found so far that the tahr numbers are okay still, the chamois numbers are okay.
I think predator-free South Westland is going to, in the short term, bring a lot of jobs and opportunity to the area, try and retain people to this place. And then long term, it's going to create this magical experience of what New Zealand's really like in terms of the birds and the nature and everything that is around.
It's about nature, it's about jobs, it's about our community, and it's a massive investment in the future of South Westland.
I've watched kaka disappear and kakariki getting very rare now. We'd love to be able to see those birds be reintroduced and recover here.
I've been here all my life, flying here over 40 years. It's a beautiful bit of country, and it's nice to see that it will be protected by government.
So this is one of 18 large landscape projects that we currently support around New Zealand. I won't go through the details of all of them, but the goal really is to crack the recipe, the puzzle for getting this elimination job done in the range of different landscapes that make up the whole of Aotearoa New Zealand, including out on the Chatham Islands off to the east. And so once we've got all the methods in place and the technologies ready, we'll be looking to roll out even faster progress across the entire country from 2030 onwards. And so our job is to support these landscape projects, and we also work on getting the tools and technologies in place that they need. So you saw Nate talking about advances with AI surveillance devices, and we're looking at cameras and olfactory surveillance and audio surveillance as well. And we're doing work on basic control devices, taking a thing like a basic kill trap, something called the DARWIN200, and turning it into a self-resetting, auto-baiting, self-reporting device that can be left out in the field for months at a time. We're doing remote comms with bait stations, and we're working on better luring as well. So this stoat at the bottom is going for a solid ceramic lure that lasts for up to 6 months in the field. And once you attach these to some of these devices or surveillance devices, you have an effective control and surveillance going on for long periods of time in the bush. We're also looking at some underpinning sciences, more technology, autonomous robotics, better use of thermal cameras, even genetics, to see are there better tools that we could be using in 10 to 15 years' time. And so how this is going, well, 8 years in already, and we're already seeing impact on the ground. We're getting the job done. And in places like Southwestland, which is where that video was just shown from, we're getting things like this happening. So these are our mountain parrots here. This is a flock of juveniles. You would have been lucky to see 1 or 2 even 10 years ago. And so the response, the feeling, being able to see the impact we're having straight away is really quite cool. In addition to the birds, we're seeing plant life flourishing on the forest floor that would have been eaten by rats and other pests beforehand. We're also seeing behavioral changes. So there's a parakeet there, second from the left. And what we're seeing now with these birds is that rather than always being in the canopy, they're actually coming down to the forest floor to forage, which is something they would have never done in the past due to the threat of rat predation. We have kiwi populations are booming, and on the right there is the mountain parrot, the kea, that I just showed you, the juvenile flock. So already we're seeing a great resurgence of biodiversity where we're doing this work. And it's not just in the backcountry, it's in the cities of New Zealand as well. So one of our projects is predator-free Wellington, for example. And this has been operating since around 2018, 2019. And again, we're seeing bird life flourishing, we're seeing the reptiles coming back, and the insect life is doing well. So we have hope that we will continue doing this work. We will keep putting the pieces of the puzzle in place for getting it done up to 2030, and then rolling out across the whole of the country from 2030 onwards to try and spread these benefits more widely. And I'll just leave you with a final video from Wellington, just to give you a taste of what the predator-free Wellington project looks like. I knew I'd forget something. Doing this work in Wellington, what it's also allowed us to do is actually to reintroduce our native bird, the kiwi, back to our capital. And so after decades of not having kiwi in Wellington, we now have kiwi living in the surrounds of Wellington City, our capital, which is and they're breeding well in the predator-free space, which is a really nice accomplishment to have already just 8 years into the mission. Okay, here's the video.
When I was a bit younger, that Wellington would be free of rats, possums, and stoats. I told them they were dreaming. We know the impact those critters have on our manu mates. So, as a self-confessed bird nerd, damn exciting to announce that we've received predator-free 2050 funding to help bring the kiwi back to Wellington and become the world's first predator-free capital. And it's not just Zealandians, it's not just reserves, it's here! Here. And here. And here. Well, maybe not there. So you're probably thinking, there's a lot of hard work to do. How's it all going to happen? Well, it already is. Check out what's happening with Kate, Jamie, and the gang at Predator-Free Coterie. So what's motivated the community? Oh,
we love it here in Karori. It's a cause that everyone can be a part of, young and old. Neighbours are meeting neighbours. We've been able to meet so many people in our suburb. It's awesome.
We've got kiddo everywhere. We've got waka numbers we've never seen before. We border onto the land there, so we're getting lots of amazing native species coming back into our suburb. We're pretty excited about bringing kiwi back to Wellington.
And it's happening all over the city. The students are doing it. Even the kids are doing it. And it's not all hard work. Become part of city life. Go for a run or a ride in the town belt, check a few traps, dodge a car, go for a drink. So let's look at how this plan's going to unfold. The scale of Wellington becoming predator-free is awesome. It runs from Miramar to Makara Beach, Karori to Churton Park, and over to the south coast. With its natural cutoff point, Miramar Peninsula, Strathmore and Seatoon area will be the first region to really target full-scale predator eradication. We're here with Dan Henry, head honcho of Predator Free Miramar. So Dan, tell us about how you got started.
We started a year ago. We had just 20 traps in a few backyards. Then we had a launch at the local community hall, and it's just grown from there. And we've now got 600 traps out across the whole suburb. We've got everyone from CEOs right down to newly arrived refugee families. We've got business leaders on board who've donated materials to build traps. Fix and Fog have thrown us a whole lot of peanut butter to bait those traps. We've caught upwards of 1,300 rats in a year, which is just awesome. And we've had people reporting an increase of birds in their backyard. But the neat thing is the way the communities come together around this common goal. And that's the exciting thing, is the way it's taken on a life of its own.
Backyard trapping is the first step, helping to get the numbers down. And alongside that, there'll be a bunch of monitoring, from sewers to compost to trucks and transport. That means when we start the intensive operation, we get the numbers to zero quickly and keep them there. This Predator-Free 2050 funding allows us to take the next big step, and we can all be part of making Wellington the world's first predator-free capital and bring the kiwi back home.
So that's just a taste of what we're doing, and this video is a few years old now, so we've managed to do it. We've managed to get kiwi back into Wellington, and we're going to grow from there. That's the end of my presentation, so happy to take any questions or comments.
All right, Dan. Well, it's been a few years since we've connected, so I'm so excited to hear about the progress. I remember when I visited New Zealand, one of the best experiences of my life was seeing a kiwi in the wild at night. And so it's so exciting that that experience can be happening for more and more people who live in the country, as well as those who come and visit. So that's really great stuff, Dan.
Yeah, no, we're pretty chuffed with where it's got to in just 8 years. And so now we've just got to keep going.
All right. So I already have questions coming in via the chat. The first one is from Talia. And they're wondering what the largest species of invasive predator is in New Zealand.
Well, okay, so the largest predator that we've got probably would be the possum. And this is a brush-tailed possum. It was brought over from Australia. And in Australia, where there's not quite so much green stuff to eat, they're quite scrawny, and they get up to 1.5 kilos. In New Zealand, because we've got so much more rain, we've got lots of nice vegetation, they get very heavy. They can get up to 5 or 6 kilos. So big, wow, fat possums. And they're beautiful animals, and don't get, they're just eating our natives. So we've got to do something about it.
Yeah, for sure. Okay, another question here from Eddie, wondering what was the first animal you found? So maybe you can go all the way back to maybe a first memory of an animal.
First memory of an animal. I can't recall the first animal I found. So I actually grew up in the UK, on the other side of the world. And so I can't tell you about the first animal I found, but I can tell you some of the first animals I studied when I was there back in the maybe 30 odd years ago now. I was actually living in the UK, but I was doing work in Southeast Asia, and I was working on birds and bats in caves in Southeast Asia. And that's what really brought home to me the love of what I do, working with nature, looking after nature.
Very cool. George is wondering, how long do kiwis live for?
Oh, you're testing my knowledge now.
They are.
So yeah. Completely. I would say around about 10 to 15 years. But you'll have to fact check me on that one.
All right. We can give them a little Google homework as well afterwards. They can confirm that age range.
Yeah.
Very
What's
cool.
the smallest kiwi that I've found? I'm looking at the questions, Joe.
Yeah, there's a few coming in via the private chat. Yep.
Yeah. Yes. I can't tell you. in weight, but in terms of size, kiwi tend to be about this big, and there's a few different types of them, and so the smallest ones would be about this big. They're very cute. They can't fly, so they're quite vulnerable. You know, they just bumble around on the ground, and that's why they're so vulnerable to these, you know, introduced predators, is that they just can't escape them.
Okay, this is kind of a fun question from Quinny, wondering about how many people get cages. So in Wellington, it looked like a lot of people were being given cages to put out and use.
Yeah. So we survey people. You know, what do you think of what we're doing? And Wellington's a awesome spot for the level of support and engagement. And so I can't tell you exactly how many people have them, but we asked them the question, do you support predatory Wellington? And over 90% said, yeah, we want it to happen. And we asked them, do you want to help with it? And over 80% said, yes, we'll help. We'll have a trap in our backyard. We'll have a surveillance camera. We'll do our bit to try and get the job done. And so that level of support from the general public's awesome.
Yeah, amazing. Okay, let's grab a question here from YouTube. Is there any new technology, Dan, that you're really excited about?
There's a couple of things coming on. We're trying to use AI quite a lot these days. So one of our challenges, you've seen these big landscapes I've shown in the videos, and behind me on the picture here, is actually once you get the job done of getting the predators out, how do you keep them out? How do you manage to surveil across these large areas? And so that should something come back in, you can respond. And so we're looking at AI thermal cameras with onboard image recognition, satellite communications that tell us if something's been detected, so we can get in quickly and respond. And so scaling up these big networks of these AI thermal cameras is going to be a big one for us.
Yeah, amazing. And then Dan, one more question for you. How often do you get out in the field, or in your director role, is it more of a in-office kind of thing these days?
It's a sad fact that you know, the more into these kinds of roles you get, where you're coordinating lots of other people, you're coordinating all the other people having all the fun almost all the time. So I do get out. I get out maybe 3 or 4 times a year. I get into cool places like you see behind me. But on the whole, I'm more of a support role, trying to give people what they need to get the job done.
All right. One more question, Dan, from Ryan. He'd like to know how long you've been in your role at Predator Free 2050.
Yeah, so thanks, Ryan. So I came into this role about 7 years ago. But this kind of work I've been doing, I came to New Zealand in 2001, so over 20 years ago. So I've been doing this kind of work in New Zealand for over 20 years and 7 years in the current role.
All right. Well, Dan, it's so great to see you. It's so great to have you share this story in New Zealand, because it really highlights what we can do if we put our minds to it, and it shows the resiliency of nature and how quickly things can kind of, if we give it space, it can bounce back.
Yeah, very quickly. It's amazing how quickly it comes back as well. You just got to give it that space.
Yeah. Amazing.
Cool.
Well, Dan, thank you so much. It was great to have you join us from New Zealand. And you never know, hopefully we get to catch up with you again on the world's most exciting classroom.
Sounds good, Joe. Take care, all.
All right. Thanks, Dan. All right. Very cool. Great to spend a little time with Dan. I pulled together a little Kahoot quiz, which we're going to do a little bit later in the event today, based on Dan's time with us and what he shared with us. But I see our next guest hanging out with us backstage. I can't wait to catch up with them. When we last left, Ranva and Maria, they were getting ready. They were all geared up, and they're about to get into the caves on a dive. I think they said it would be about a 2-hour dive that day. So really excited to bring them in. Let's get them in live from Indonesia. Ranva, Maria, how are we doing today?
Good.
Hi, Joe. Nice to see you.
So great to see you both. It's nighttime for me. You're 12 hours ahead, so it's the morning for you. I just want to get right into it. How have the last few days been? How's the last week been going?
Oh, it's been going really well. It's been really busy. Our team has been working all day, every day. Like after dinner, the team goes straight back out, sits on their laptops. So since we saw you last week, our dry caving team have discovered no more than 3 new cave systems all around the Lau Laui cave system area as well. And so that's on top almost, but underground in the dry section. And the divers, in the meantime, had now been diving everything underground to see what we can find. And the map is now slowly starting to take shape. And we can see that the map and where the new cave systems are found, they're slowly moving towards each other. We've not connected them yet, but so far we have underground for the divers, we have mapped about 4.2 kilometers of new cave. So that's really exciting.
Amazing. I have an image here of that map. Is it okay if I share it now?
Absolutely.
All right. Give me a second to load it up on my screen. There we go. Should be able to see it now. So the yellow pin, that must be where you guys were last week at the dry cave section?
Yes, exactly. Yeah. This is the start of the cave where we are entering the water from. And when Ranva is saying that everybody are going back out to work after we've had dinner here in the evenings and sitting on their laptops, this is what they're doing. So as the dry cavers are moving around in the dry parts of the caves, us divers, we are moving underwater, and we have some videos of that coming up where we're exploring new passages and laying line. And what you see, the red line here, is actually the line that is running underwater, put on top of Google Maps, so we can see the direction of the cave. And as the moment, the theory is actually being proven that the water is running from north to south, but we're also seeing that it is fracturing out into east and west. So we're spending the next couple of days looking in the area on both sides of this main tunnel running.
Okay, that is so cool. And I can see, I can already guess, looking towards the left, that it's probably going to connect somewhere, and maybe further towards the top portion. It's really exciting exploration because nobody has ever been in these places. It's pretty wild.
Yeah, it's amazing. I think that's really catches the true essence of exploration, being the first ever to go around the corner and see what's there. It's pretty amazing, I have to say.
The first video you have, Joe, is actually showing just that. That shows us diving into a tunnel that has never been dived before. And if you start, we'll talk it over as you see how it looks. So this is actually one of our team members, Natalie. She's on the push team. So this means her job is to dive into the tunnels that hasn't been visited yet. And you see she's pulling a string in her left hand. She has to use this line because basically it's your lifeline. As it's first time she's diving into this tunnel, you see a lot of percolation, a lot of silt coming in the water, and that just means nobody has been here before, and it's a tight place. We do go in tunnels that are huge as well, but this one is particularly tight, and without this guideline, it's going to be really hard to find your way out of the tunnel again.
That's actually even true for the big tunnels, because some of the big tunnels here in Laulawi are so huge that it's actually quite easy to get lost in there. So these lines are, like Maria said, are lifelines.
And it's always fun to be number one like Natalie, because she can see what's ahead of her, but I'm filming behind her, and you see now it's starting to get really milky. And I tell you, after going through this passage, it was like diving in a glass of milk. And I have my hands on this line all the time. But coming back to this place a few days later, this silt will have settled and we can keep pushing this particularly line.
All right, very cool. At this stage, I want to remind those joining us that if you want to start putting questions into the chat, the private chat, or in the comments section via YouTube, please start doing so now. We'll start mixing some questions in for Ranva and Maria as well. Okay, well, let's keep going. I want to get back into that cave system.
Yeah, the next video is from the mapping team. So once this line has been laid by the push team, the mapping team then comes in and start drawing down the map. And this is very, very important for several reasons. We want to see the map that you had before with the red line on Google Earth. We want to see the size of the cave system. And one of the reasons why we do that is if we understand where it's running, we can also understand where the water is added from. So we're out here to start a geopark for the area, because the scientists believe that it is unique both for the geology. Sorry, this is us talking underwater. We can actually kind of understand. Each other.
having an amazing time.
This is Natalie.
Beautiful.
Sorry, I didn't know that there was so much sound in there. So anyway, so mapping out this, we can actually see the area that the aquifer is being replenished in. So we can't just protect where the actual cave is, but also where the water basin is starting from. So as a mapper, you will have to be on the line, taking directions of compass and depths and distance. And that is what Natalie is doing in this video.
And also a quick note to the talking in the video. Although we're underwater, the equipment that we're using here are rebreathers. And because rebreathers have no bubbles, you can actually, it's really silent and quiet, and you can actually talk to each other, but you have a mouthpiece in your arse, so you have to talk like this to each other. It can be a little bit difficult to understand, but if you know each other well enough, then you know what the other one is saying.
Mm-hmm.
Oh,
All
some
right.
good questions coming through.
Yeah, I'm going to pop in with a
Nice.
few of them.
Yeah.
Asha and Hayden both are curious about the lowest point or the deepest part of the system that you found so far.
So far, the deepest point in meters is 21 meters. This is actually a fairly shallow cave, one of the more shallow caves that we have dived. First, like the first passage is down to about 6 meters, and you dive about 80 meters or so, and then you come to this beautiful underground river that goes for almost a kilometer. And here you're actually at 0 meters to about 6. And then you're diving through lots of different, like, big rooms, tiny rooms, little restrictions, and then another big room. And then it starts dipping down again. And then the average depth is between 6 to 12 meters, with some of the side tunnels going a bit deeper to about 18, 19 meters.
All right.
And that is actually talking into a lot of the questions as well. It's talking about the science, and what Ranma is talking about here with the deeper passages. This is one of the tasks for the science team. So we need to go in and retract data from the different parts of the cave. So both the freshwater, the salt water, and the deeper part and the furthest part. And so far we have done 4 stations of different data samples. Yeah, exactly. I think you actually have a video from that, Joe, and that can explain a little bit more.
All right. It's loading up right now, and it should start.
Ram and I have prepared our scooters to go and collect today's data samples. We will be heading into station 1, 2, 3, 4, which is already positioned in the cave. We will be collecting fossils of shells and corals, and then we will install station number 5, where we will be doing water samples for DNA, and then we'll also be doing sediment samples, and we'll be collecting fossils there as well. We have been we've been giving these falcon tubes, so now we need to start sampling actual live specimens in the cave. For the dry cave team, they'll be heading down into Laui Laui and continue the exploration of the different areas. The cave is also heading south, we've learned, so besides having an upstream part of the cave, we now also have a downstream part of the cave. Now I will shut up and get ready.
So, actually, even since Maria has recorded this video, which was like, 4 or 5 days ago, we've already been yesterday to explore the downstream section, but unfortunately, as of now, that's not yet leading anywhere. So it's really exciting being out here. There's amazing and exciting developments every day, plus a whole bunch of challenges too.
I can quickly answer some of the questions in the right. How cold is the water? 27 degrees. The last dive yesterday was 4 hours long, and we find a lot of exciting stuff because, as I said in the video, this is an old ancient coral reef. So we see fossils or shells and clams and different types of coral that are perfectly pristinely intact down there. So one of our tasks, as I say in the video, is go and get these samples for the scientists. And we already now know that Ida, who was on the last episode of DARWIN200, has been back to the lab looking through her DNA samples, and we do have DNA in the material that we sampled last week. So this is very exciting.
Very cool. Talia would like to know how long the two of you have been diving for.
Oh, I can start. I learned to dive in Australia in 2008. So that's what, 16 years?
Very
I think.
nice.
Yeah, and I am now running on 22 years of diving. I was 15. Oh, wow, no, so there's more. 24 years of diving. I was 15 when I learned. And yeah, like that's all I've done ever since. That's my life.
I think Sienna's got a question that a lot of people tuning in probably have is those squeezes. Is it hard to get through some of those squeezes with all your gear?
Well, it can be. But it's just about, it's just about keeping it slow. We have a saying in scuba diving, like if there's anything, like, oh, there's a situation, the first thing you do is just stop everything that you're doing, and then you breathe. Just catch your breath. And then you think, what's the next logical step? And then you act. So if it is that you are going in through a squeeze like that and you find yourself stuck, instead of then rushing around trying to get out, you can often make yourself more entangled or get yourself into more trouble. So the best thing you can do is just completely stop and then just try slowly to figure out how you can get through. And then you wiggle a little bit and then you gently go through again. Like you saw in the video earlier, Natalie is going very, very slowly through those passages. Yeah. And that's what exploration in tight passages means, that you just go slowly ahead.
Yeah, but definitely there are some of them that are too tight and we can't go through. It's also about not taking chances. We are very far from everything out here. So every single dive, we have to calculate the risks of going through these bits and pieces, because cave diving obviously needs a lot of training and also some caution.
How's the Starlink been working in the field for you?
Good, really good. We need to figure out the tilting of it, but we're on the Starlink now, and it seems to be working perfectly, right? And it's the same thing last, right?
Yeah, really good connection.
So pleased.
Yeah, let me grab this question from Eddie. Or no, this isn't from Eddie. It doesn't have a name, but it's your gear. How heavy is it when you're not in the water compared to when you're in the water?
Pretty heavy.
Yeah. We have how many steps walking out of the cave?
108.
108 steps, which is when you dive for 4 hours and you're tired and you're hungry and you're thirsty, the gear becomes really, really heavy. But getting out of the water and having some chocolate is cookies is a good lure for us going up those stairs.
But here we have some amazing help from some local guys here who are helping us carry some of this equipment up and down these stairs. The temperature outside is about 32 degrees during the day, and the humidity is up to about 90%. So, and we're diving in dry suits as well, which are kind of needed when you're doing this long dives. Also, it helps with redundant buoyancy. So without these amazing people helping us out, we wouldn't really be able to do it, at least not safely.
No.
So for the Sidewinder itself, that's about 15 kilos. Yeah. And then each tank is what? I don't know. I can't remember how much tanks weigh.
I think we're carrying about 29 kilos total. Yeah, without the tanks. We don't carry the tanks, as Ran was saying, not on this rebreather.
No, but we do attach them underwater. So if we were to walk with them, it will be about 40 kilos.
Yeah.
And then we have the underwater scooters as well, which is an additional 5 or 6. So you have to be really strong when you go cave diving.
Pretty loaded up. I see you're rocking your Explorer's hat or your Explorer's Club cap today. That's pretty cool. And you'll know, you don't know this, but I recruited someone you guys might know. Mr. George Karunis is coming on board in a couple, actually next week. He's finishing the ship in New Zealand and sailing to Sydney.
Nice.
Yeah, he's stepping in.
Yeah, cool. It's such an amazing community of explorers, and that's the same that counts out here. I mean, everybody out here with the same purpose, but what is incredible about projects like these is you have people from different background. Some are scientists and super into their little tiny area. And then there's somebody else like us. We're not scientists. We're just passionate divers who are specialized in this type of diving. And together we can form these bridges and get data that can help preserve the area. Just like you are doing with the DARWIN200, assembling people with different skill sets to make a difference, because we do need to make differences. And we're out here trying to show you guys that it is definitely possible and it can be fun as well.
Absolutely. Well, I know that you guys will be heading to the dive site shortly, but I want to ask one more question before we say goodbye today. And that is, what do the next few days look like? What are you going to be getting into?
What day is it today?
Yeah.
I think it's Thursday, right?
Yeah.
It's Thursday. So
Thursday for you, yeah.
Yeah, we have 3 more days of diving. So today, Maria and I are going to be pushing a few leads, see if we can find some entrances to the west. Then every evening, we all sit together and work on the maps and find out what the dry cavers have found. We also need to shoot some video as well. Yesterday, we were actually diving with a really big underwater camera rig. And it was kind of like Star Wars in the sense that the camera was facing us. So it's a bit challenging diving inside a cave when you have light in your eyes, everything's lit up, you can't see where you're going, and you have this very heavy, almost tank that you're trying to steer around inside these caves. But we've been told the footage is pretty amazing, and we might be able to show you something next week.
Yeah, but when Anna says 3 more days of diving, that's before we have a day off, where we're going back into the village, showing some more footage, talking to the people in the village. We had an amazing session on Sunday where they gathered the whole village. There will be even more people this time, talking about water preservation, geology, geoparks. But tomorrow we have another scientist arriving. He's a hydrologist. Actually, 2 hydrologists are arriving from the University of Gajah Mada. And then we start looking into the flow of the cave. So we're very excited about having more joining on the science team.
Excellent. Well, good luck over the next few days. We can't wait to connect next week. And thank you so much for taking some time. I know you've got a very busy schedule, so thanks for being with us today.
A pleasure. Thank you for all the good questions.
Yeah, thank you so much for the good question, guys, and I hope to see you all next week.
All right, sounds good. Thanks, Rama. Thanks, Maria.
Bye.
Talk to you soon.
Talk soon.
All right, there we go. So we have been bouncing all over the world. I'm here in Canada. We had Dan in New Zealand. We've got classes hanging out with us in Australia. And then, of course, we had Ranva and Maria with us in Indonesia. So we've covered a little bit of ground across our amazing planet here on the world's most exciting classroom. Now, we have a lot to do in the last few minutes we have together. So let's get right into it. I have a Kahoot quiz that I got ready while Dan was presenting today. So I'm going to hit start on my end, and then I'm going to share my screen so that you can see it on your end as well. So it's just loading on my end. I'm going to move it over for us. There we go. All right. Now I need to share my screen and we're good to go. As always, right answer are going to get. So you need to go to kahoot.it, and our PIN number today is 626885. If you have a device handy, you could also scan that QR code and it will bring you right in. So we'll give it a couple seconds to get a few groups in here with us, and then we will play our Kahoot together. Then we have our experiment to take a look at. We have a brand new experiment this week. And then from there, we are going to wrap up with our curiosity. So a few more things to wrap up over the next 10 minutes or so, and then we'll sign off for this week. Next week, we'll connect again, and we're going to have a live connection from the ship, which should be really, really cool. We haven't had one of those in our Australia/New Zealand world's most exciting classrooms. So I'm going to give it maybe 10 more seconds here to see if we can get a couple more groups in, and then I am going to get this Kahoot going because we have a few more things to finish up today. All right. I think we're pretty much ready. I don't know if we're going to get too many more groups in. Let's see. Oh, there we go. A couple more popping in. I'll give it another couple seconds, and then we are going to go live. All right, I'm going to hit start now. You'll get a 3-second timer, and then we will be into the Kahoot. All right. Here we go. First question coming your way. Where is Dan? Did Dan connect with us from today? Was it in Australia, New Zealand, Fiji, or Chile? Where did Dan connect with us today? All right, good job, crew. It was in New Zealand. Let's go on to our next question. A quick stop. We've got the quick swan hanging out there in first place. Let's get to our next question. All right, 30 million years ago, New Zealand was mostly underwater. Is that true or is that false? That's 30 million years ago. Oh, there we go. That is absolutely true. It was a very different looking place. And it led to the loss of those land mammals for the most part. But our next question relates to that, so let's get into it. All right, next question coming our way. How many native terrestrial mammals can be found in New Zealand? Was it 2, 4, 6, or 8? So this means that they belong there. So how many native terrestrial mammals? Good job, crew. There are 2, and they are bats. Everything else didn't survive that period when most of New Zealand was underwater. But as we know, we learned from Dan, humans brought a lot, over 30 species of invasive mammals. Okay, we have a true or false coming our way. 50% of bird species are under threat from invasive mammals. Is that true or is that false? That 50% of bird species in New Zealand are under threat from invasive mammals. Got a couple more seconds to lock in your answer. Oh, we have a split there. It is false. It's actually 80%. 80% of bird species in New Zealand are under threat from non-native invasive mammals. Okay, let's see here. So shout out to the smart newt. In second place, we've got the champion ostrich, and holding down that top spot, we've got the quick swan. All right. If you are the classroom that contains the quick swan, I need you to send me a message to classroom at DARWIN200.com. I'll pop that up on the screen here really quickly. Classroom at DARWIN200.com. There it is. Okay, we're going to jump into a new experiment. So remember, last week we had our experiment with the shells. So we were putting shells in vinegar, shells in water. We weighed them beforehand, and we were going to see what happens to those shells over a period of several days. So you still have your classroom 1 more week to try that experiment. Send me in some photos. I already have some photos sent in from some classrooms, which is really, really cool. But we're going to do a brand new experiment today, and you'll have 2 weeks again to send in some results from that experiment. Send us some pictures giving it a try. So let me share that video here with us right now. Let's make sure I pick the right one. And here we go.
Welcome back. This week's experiment explores the process of osmosis. This is how water molecules move from areas of high concentration to low concentration. The walls of plant cells have semi-permeable membranes, and through osmosis, this allows the cells to either expand or shrink depending upon the direction the water moves. This is how the roots of plants absorb water from the soil. But osmosis can be harmful to certain organisms in certain habitats. For example, if you took a saltwater fish, such as a clownfish, and put them in a freshwater environment, it would quickly die. And the same in reverse. If you took a freshwater goldfish and put it in the sea, it would also quickly die because of the osmosis effect on its cells. In this week's experiment, We're going to look at how osmosis impacts gummy bears. To run this experiment, you need 3 beakers, one with 2 teaspoons of salt, one with 1 teaspoon of salt, and one with no salt at all. You then need some fresh water, such as tap water, a set of scales, a ruler, 3 nearly identical gummy bears, and a results sheet, which you can download from the DARWIN200 website. Okay, let's get started. First, let's make our solutions. Pour in exactly the same quantity of water into each of the 3 beakers. I'm going to put in exactly 75 millilitres into each of these beakers. And the last one with no salt at all. Make sure you dissolve the salt. Mix the solutions very carefully. Make sure you also make a note on each beaker of the different solutions. So I've put a big S here for the solution with 2 teaspoons of salt, a small S here for the solution with only 1 teaspoon of salt, and no salt at all for the beaker containing the pure water. Then you're ready to weigh and measure your gummy bears before the experiment. So use a set of scales and very carefully put on a gummy bear. This one weighs 2.2 grams. I'll put that in front of the no salt solution. This one weighs 2.3 grams. I'll put that in front of the weak salt solution. And this one weighs 2.3 grams. I'll put that in front of the more concentrated salt solution. You then need to measure the length and the width of your gummy bears to see how they change as a result of your experiment. This one is 21 millimeters long and 12 millimeters wide. So make a note of that so you can compare your results afterwards. This one is 22 millimeters long and 11 millimeters wide. And the last one is 22 millimeters long and 12 millimeters wide. So we'll make a note of that too. So they're all very close in weight, length and width. Now put 1 gummy bear in each beaker. So put 1 in the fresh water, 1 in the weak salt solution, and 1 in the much more concentrated salt solution. You then have to leave your experiment for 24 hours. Come back after a day and see how each of the gummy bears has changed. Note down what changes you observe. Which gummy bears have grown bigger or smaller, and why? And how does this relate to the concentrations of salt in your beakers? Send in your answers to classroom@darwin200.com or upload your results via our website, www.darwin200.com. Please join us in 2 weeks and we'll find out the results and the reasons why these gummy bears change.
All right, so there you go. There's your challenge for the next 2 weeks. You don't need too many materials to do this experiment. Some beakers, some water, some measurement material, and you should be good to go. And something like those tasty gummy bears. So you should definitely have extra that you can share with your students. Okay, so to wrap up for today, we have to do our curiosity of the week. Last week's curiosity was a really tricky one to get us started. We did have some great answers come in from classrooms, but unfortunately, nobody had the right answer this week. There were some great guesses, especially from our group in Naracoorte in South Australia. They had guesses like a wreath, a door hanger, shell rings, bird feeders, all kinds of things. What else? Circle, something that washed up from the ocean, Christmas decorations. So there were a lot of really good guesses, but I'm going to play the video and you will find out from our expedition leader, Stu, what the curiosity actually was. Here we go.
This week, we asked you what these objects here are. It would be easy to guess that they are necklaces or some kind of jewelry, but they're not. The answer is shell money. They come from Papua New Guinea, specifically an island called New Britain off the coast of Papua New Guinea. And still to this very day, These amazing bands of shells are still used as currency, particularly in local markets for trading and bartering. So if you guessed shell money, you were right.
All right, so there we go. Those are actually a form of currency in parts of Papua New Guinea. That's really, really cool. To be fair to those who gave it a shot, I didn't know what it was the very first time either. That was definitely a very tricky curiosity of the week. There'll be some that'll be a bit easier and some that'll be more trickier than others. We've got a brand new one for this week, so let me play it for you right now.
Next curiosity is this little creature here. This animal has an amazing story to tell, which we'll explore in next week's session. But your task is to work out what type of creature this is, or what group of animals it belongs to. Send in your answers to info@darwin200.com. Thank you for joining, and see you next week.
All right, so Stu put info at Darwin200 there, but the best spot is classroom at Darwin200.com. We will still get it at the other one, but we check the classroom at Darwin200.com more often for answers from our classrooms. So there we go. That was another really, really busy World's Most Exciting Classroom. We bounced all over the world together today. We visited multiple continents. We met some amazing people. We learned about conservation and cave diving. Yeah, lots going on in the World's Most Exciting Classroom. The last thing we have to do before we say goodbye for today is a shout out to our sponsors, our supporters, our partners, without whom we wouldn't be sailing around the world, having these classrooms, bringing young conservationists on board and researchers. They really make the Darwin 200 possible. So goodbye from me for this week. I can't wait to see our groups joining us next week. For now, let's sign off with a shout out to our supporters.